Hey guys, so welcome back. We're going to do lesson number 18, where this first example that you guys see is very similar to what we've done back in multivariable. We're actually looking at dot products, and we're also looking at magnitudes and then the unit vector. So in example number 1, it says compute each of the following given that U is this matrix here, V is this matrix, and then W is this matrix. The first thing that I want you guys to notice here is that these are all 4x1 matrices. So if I ask you to multiply, let's say V times W, we know we cannot do that because we have a 4x1 matrix and we're going to multiply that by a 4x1 matrix. Well, you guys know that that's not possible because these numbers have to be the same thing. So that's very similar to the properties of the dot product. I cannot dot V with W and then having the same dimensions. So what is an easy fix with this actually is we're actually going to transpose one of them. And so in this case here, we're going to transpose our V, and that's actually nice to do because we're going to have, if a 4x1, we're now going to have a 1x4, right? And so we can actually have V transpose as 1x4. So we're going to make our rows our columns. So V transpose is going to be -1, 0, 2, and 5. And now we can dot this with W because W now is a 4x1. So we can go ahead and just write W down, recopy this. And just now we'll go ahead and do our dot product. Now remember the dot product is scalar, so you will get a value of this, just a number. And so just remember, guys, that we're to multiply the first component in our V, which is -1, and we're going to multiply that by the first component of W, which is positive 4. And we're going to do the same thing down the line here. We're going to take 0 in our transpose of V, and we're going to multiply that times -3 in W. And then likewise, we're going to multiply 2 times 0, and then we're going to add to that 5 times 6. And then our answer to this problem is going to be -4 plus 30, because these are all both 0, and we're going to get that the dot product of VW is 26. Okay, so for example B, you would do the exact same thing. So you will just find what the difference is first of V minus W. Well, the difference of V minus W is very similar to when you guys were working with vectors. You'll take V, which is -1, and you're going to subtract 4. You'll take 0 minus 3, you'll get 2 minus 0, and you'll get 5 minus 6. So we're just creating our own vector here, matrices here. And so when we do our V minus W, we get -5, we get -3. Oh, sorry, actually, it should be 0 minus a -3. So it should be a positive 3 here. My apologies. 2 minus 0, and then -1. All right. And now what we're essentially going to do now is that we would actually transpose U, because again, we'd have the same issue. We had an example A where we're going to have a 4x1, so we would transpose U, our very first one here, and so we're going to have that transpose U is going to be 2, -1, 3, 2, and we're just going to dot that with our now U minus V, V minus, Lord, V minus W, which again, L has become -5, positive 3, 2, and -1. And then when we do the same thing we did up here, you will get a value of -9. So you can do the steps and just verify that that's the value that you get, is -9 for this problem. Okay? All right. Then the next question is actually asking us to find the magnitude of U, right? So that's what part C is. So what I'm going to do is just put it up here so I can keep U in my sights right this. So, well, what's the magnitude of U? Well, this is just going to be the square root of all of the components of U squared. So the magnitude of U would be U, the first component of U, which is 2, and that is going to be squared. And then we're going to do -1 squared plus 3 squared, and then 2 squared. And so the magnitude of U is going to be equal to the number of 2 plus 1 plus 9 plus 4, sorry, 4 plus 1 plus 9 plus 4, which is going to give you the square root of 18, which is going to give you a value of 3 square roots of 2. Okay. And then the last question is actually asking us to find what the unit vector is for W, right? So down here in part D, it's asking us to find the unit vector for the direction of W. So what I'm going to do is just, since again, I want to keep W right here, I'm just going to go ahead and clear my screen and write down what this is. Well, the first thing we have to do, remember that for a unit vector that we learned back in multivariable is going to be the actual vector over the magnitude of that vector. So we already know what W is. It's 4, -3, 0, and 6. We have those components. So that's what this is going to be. So this W is going to be the 4, -3, 0, and 6. So we just have to find the magnitude of W, which is, again, very similar to what we just did in part C. We're going to take the square root of our components of W, and we're going to square them. And we're going to get that this ends up being the square root of 61, right? So not something that's really nice for us, but the square root of 61. So friends, all we have to do now is actually just take W, and we're going to write out all the components. Sorry, that's not straight at all. We're going to take the component of 4, and we're just going to divide that by the square root of 61. We're going to take all of our components. So we're going to take -3. We're going to also divide that by 61. Then we have 0, and then we're going to do 6 divided by the square root of 61. So this is going to be the unit vector in the direction of W. It's these values for, again, it's very, very similar to what we did in multivariable. So this should be a pretty easy one for you guys. Just again, we did this back in multivariable. So hopefully this made sense to you guys, and I will see you back in the next video. Take care.